Hello students, today was JEE Mains 2017, right? Exam. I hope you have done your exams very well. Now let's move on to the video solutions for JEE 2017, and the code which we are going to discuss is code D. So let's begin with the organic chemistry question. So you have a particular compound over here and the question says the correct sequence of reagents for the following conversion will be, so you have been given 4 options. So in this particular compound, if you could see here, this is a bifunctional compound because this contains both an aldehydic as well as ketonic group. And if you could see here, the product is again an alcohol, right? So this C double bond O becomes OH, this C double bond O becomes OH, right? Which can be achieved by directly using Grignard reagent, right? So let's see what exactly could happen in these cases. Now you might be knowing that Grignard reagents reacts both with the aldehydic group as well as the ketonic group, right? So what exactly would happen? So let's have a look. Let's see our first option, which is Grignard reagent, and then you have H plus in presence of CH3OH, and then this is basically ammoniacal silver nitrate solution. This is what you call it as Tollens reagent. Okay, so what exactly would happen? Now just see what would happen if you use the first option. So if the first option is incorrect, then you can directly eliminate the second option as well. The reason is, in the first and second options, both methyl magnesium bromide is common. So now let's have a look. So let's say if you have something like this, so you have a C double bond O, and then you have a C, you have an H, you have double bond O, correct? Now let's say what would happen if you treat this with Grignard reagent, that is methyl magnesium bromide. Correct? So let's say if we take 2 moles of methyl magnesium bromide. Now if you could see here, oxygen is partially negative, so this is delta negative, this is delta positive. Again this is delta negative, this is delta positive. So what would happen? In Grignard reagent, methyl group is partially negative and MgBr is partially positive. So what would happen in this case? So I would directly write down the product. So CH3 would go with C and MgBr would go with O. So the first product which you would be getting is this. So it's going to be something like OMGBr, and then you would be having something like a CH3 over here, correct? Similarly, the second carbonyl group would also undergo reaction with Grignard reagent, right? So what would happen? So again, CH3 will go with C and MgBr will go with O. So you'll be having CH, then there is a CH3 and there is an OMGBr, correct? So this, let's say if this undergoes hydrolysis, what should happen? If this undergoes hydrolysis, definitely you would be getting a compound OH, CH3. So the first part is okay, but if you could see here, the second part, carbon is connected to hydrogen, then you have a CH3, then you have an OH. So if you carefully look at this, this is H and this is CH3, right? And this OH is intact over here. So that means if you use Grignard reagent, we may not be able to achieve the desired result because the next set of compounds are H plus in presence of CH3OH, right? So what would happen in this case? This is an alcohol, again this is an alcohol, so they may form an ether. That could be one possibility, right? So you may never get the desired product by using this particular reaction route. So I'm just trying to put a cross over here. Now let's see the second one. You would be getting the same compound, but in this case, instead of H plus and CH3OH, we have Tollens reagent. So basically there won't be any reactions as such, right? So even if there is reactions, the product which will be obtained won't be the same what we want. Correct? So these 2 options you can eliminate. Now comes the third and the fourth option. So what would happen if you treat this with a Tollens reagent? You already know that Tollens reagent reacts only with the aldehyde group and converts it into carboxylic acid group, right? So if this is treated with Tollens reagent, that is AgNH3 twice plus an OH minus, right? So this COOH would get oxidized to, this CHO would get oxidized to COOH, and then finally you would be getting something like this. So you will be having the ketonic group which is untouched, and there will be CH. Okay, I would simply write COH, right, instead of CH, and then there is C double bond O, correct? So if you could see here, the second step the second step is again Grignard reaction. So if you could do the Grignard reaction over here, again there will be complications. Grignard reagent will be reacting with both of these, and again you won't be getting a proper product, correct? So let's have a look at the fourth one. So if you could see the fourth one, the first set of reagents are same, so it would be corresponding carboxylic acid, and then the next is H plus in presence of CH3OH, correct? So if you could see here, this is an acid and this is an alcohol. So this is nothing but an example of an esterification reaction. Okay, so this is an example of esterification reaction. So what would happen over here? So I'm going to write down the product directly. So basically this H and this OH would be going off in the form of water. And of course this is acid catalyzed, right? So it's esterification. So I would be getting something like this, C double bond O, and I'm going to write this as O with a CH3, correct? So this is the product which you would be expecting. Now, if you treat this with Grignard reagent, which is CH3 MgBr, what would happen? Now let's have a look. So we already know that this ketonic fragments, when react with Grignard reagent, it forms a corresponding alcohol. So let's write down there itself. Okay, so I would be writing directly. So this is going to be OH and this is going to be CH3. If you could see here, I've already done this. Now the trickier part is this particular fragment, how this particular fragment would react. Now carbonyl group, in carbonyl group you have oxygen is partially negative, carbon is partially positive. So MgBr would be partially positive and CH3 would be partially negative. So what exactly happens? CH3 would go here, MgBr would go here, and as a result of which you would be getting C. Now this is connected to OMgBr. Okay, so I would write O minus MgBr plus, correct? And then I'm going to write this as OCH3 here. Now the Grignard reagent methyl group is going to come here. Now there was a purpose of writing this as O minus MgBr plus. So you might already be knowing that all alkoxy groups are very good leaving group. So this bond shifts here because there is an extra lone pair, and OCH3 group leaves as a very good leaving group, as a result of which you get a carbonyl compound again. So you would be having an OH here, there would be a CH3 over here, correct? And then there would be a C double bond O, and there would be something like a CH3, correct? Now this is pretty much easier to solve. Okay, let's have a look at the byproduct. So byproduct, I would simply write it here as minus MgBr, and then you have OCH3, correct? So what exactly would happen when this is again treated with a Grignard reagent? So what would happen? Excess of Grignard reagent, what would happen here? So it's pretty much simple. This is partially negative, this is partially positive. So CH3 would go here because the bond gets polarized. So partially negative, partially positive, correct? And MgBr would go with O, as a result of which you would be getting OH, CH3, C, CH3, and then OMgBr. So I'm going to write this in two steps directly, and MgBr and H3O plus, correct? So it becomes OH and the CH3 would come here. So this is what exactly we wanted, correct? So you have at this position OH, CH3, here it is CH3, CH3 and OH. So we could easily conclude that the first three options are incorrect, and the correct answer is option 4. Okay, so this is the simplest way of solving, even though this is a little bit lengthy, but this is how it has to be. Okay, so if you could see here the first two options you can easily eliminate, because if you even look at the second set of reagent, you could easily conclude that that's not the correct one. And third and fourth, there is a tie, right? But if you could look at the second reagent, if second reagent is used, then it would give some other product and not the desired one. So the fourth option is the correct option to this question number 77. So the correct answer for this question is option number 4.